Hello, my 7th graders. Thank you for joining me for your very first math lesson. For those of you following along at home, this is out of the Saxon 8-7 book, this guy right here. Make sure it's your 2nd edition, not the first one. And it'll say 2nd edition right down there at the bottom. Okay, so for those of you who are in my class and that are watching this, what I want you to do now is go ahead and get out that binder with the dividers in it, and that section that is labeled notes or videos or things like that. What you're going to be doing now is you're going to follow along with these examples that I go through from the book. So you'll be writing down those examples, then we'll be practicing the practice section together. All right. So if you're following along with the book, I'm on page 1, lesson 1. Got to start somewhere. We're going to be talking about arithmetic and whole numbers with money. Arithmetic with whole numbers with money. If we jump forward to, and again, this is going to be a reminder for a lot of you, but I just want you to get a good familiarity with it. And plus, you may learn something new. I may do something a little bit differently than what you do. Okay, if on page 2, we've got our first example. It is 36 plus 472 plus 3,614. Good. When we're adding these up, we want to make sure the first things first, we can actually add in any order, right? 7 plus 10 is the same as 10 plus 7. So with that said, all these guys right here, we can add them up in order. I say that because I like to start with my digits that are the largest, right? So I've got this guy right here that's 4 digits. I'm going to start with that guy. We're going to line these up nicely. After that, I have this guy right here. You see I'm lining those up? Then I got 36 here. Again, so we're going to line these up here like this. Now, in order to add, we add up, oh, see I put a little lines through there. We add up this whole column. So we get 4 and 6 is 10, plus 2 more is 12. 7 and 3 is 10, plus 1 more is 11, plus another is 12. 6 and 4 is 10, plus 1 more is 11. And I'm carrying those up to the top. I'm carrying my tens place up. If you aren't familiar with that, let me know and I can get you some videos for I can recommend some other videos. Okay, so my answer here would be 4,122, not 122, it's 4,122. And means decimal, and we're not quite there yet to talk about decimals. All right, so let's talk about this next one. These Saxon books really like to use dollars in order to reinforce all those basic operations: addition, subtraction, multiplication, division. And I really like that. But what you will encounter is this. Before we get into this example, if you see 25 cents at the store, it's usually written like this, right? And that's saying part of a dollar, right? Part of a dollar. Sorry about my phone there. So that's part of a dollar. Now, what you will see in the Saxon book, and though I don't see it very often out in the real world, is this. And actually, I think that sign goes at the back, like this. This is 25 cents. Now, I want you to be real clear here. If you're using a decimal, you have to use that dollar sign. You don't want to use a decimal for this. Otherwise, you're telling me a portion of a penny instead of a portion of a dollar, okay? So if you use the decimal sign, you got to use your dollar sign here, all right? Now, another thing that I want to talk about is invisible math. I like this. Invisible math. All right. Go ahead and write this one down, folks. If you don't see a decimal, it's at the end. So it's at the end of your numbers, okay? If you don't see a decimal, it's all the way at the end. So 17, you're gonna have a decimal right here, okay? Now, where does this come into play with money? So let's back up and talk about, so 25 cents, that was a good example, right? Oh, I keep putting the cents in the front. 25 cents, that converts to $0.25, right? So 17 cents is going to convert to 0.17, okay? 60 cents is going to convert to 0.60, so 60 cents, just like this. Here's where it's tricky, guys. If you have a single digit cents, something like 7 cents, it is not 0.7. No, that's 70 cents. Not that at all. What we have to do is, you see how all these other ones have 2 digits? We've got to put a digit in here that keeps it the same, okay? That keeps it equal to all of that. And the way we do that is we do $.07. 0.07, right? We can add a 0 at the beginning here because that won't change the value at all. We can't add it at the end because that'll make it 70 cents. So with that in mind, now we can move on to example B, or in example 1, part B. All right, so this guy says $1.45 plus $6 plus 8. Oh, would help figure out the number, huh? Plus 8 cents. All right, so we're gonna write this in vertical order, and the key here is that those decimals need to line up, okay? Go ahead and write this down. Adding and subtracting, okay? Line up your decimals. It's math tutoring, not spelling tutoring, kids. All right, so line up your decimals, okay? So how do we do that for this example here? Make sure you've written that down. So we've got our first one, which is $1.45. $1.45, okay? Now, think back to those notes that I just had you take. If you don't see a decimal, it's at the end. So in the $6, right here at the end. So we do this. Now, personally, I like to throw in a couple of placeholders so that my decimal doesn't get lost and I can keep everything nice and lined up there. So I'm gonna throw some zeros right here, okay? And then we have 8 cents. And again, the decimal's at the back here. However, we're converting it from 8 cents to 8 cents written like that to 0.8 cents of a dollar, like this, okay? So 0.08. And again, I'm gonna put a little placeholder right here so that I don't lose my spot. So we're gonna take all these things, we're gonna line them up. When we do this, we line up our decimals and we bring our decimal straight down. Now we just treat it like a normal addition problem. So 8 plus 5 gives us 12. Ah, almost made a mistake there. 13. 13. 4 plus 1 gives us 5. 6 plus 1 gives us 7. And we have $7.53. $7.53. Excellent. All right, so looking at example 2, now we're going to deal with subtraction. Oh, the other thing I want you to write down. Sum equals addition. When you hear the word sum, S-U-M, not S-O-M-E, addition. That means addition. Okay, it means the answer to an addition problem, or just addition. That works too. Difference equals the answer to a subtraction problem. So make sure you write those down, flag those, give them a little star because you're going to be coming back to that a couple of times. All right. So with all that said, we have now, in example 2, we're going to be doing some subtraction. So we're going to be finding the difference between, the first one is 5,207 and 948. Now, I should write it down the way the book shows it, it's written like this, 948, right? But we know that it's easiest for us if we line everything up. So we're going to rewrite this as 5,207 and 948. All right, so quick reminder on this, if you have the smaller number up top, that gives you a negative number. We can't do that, so we need to borrow from our other columns, okay? So we're gonna borrow from, but we can't borrow from a 0, so we're gonna go all the way over here, we're gonna make that a 1, okay? Now we make that a 10, now we can borrow from it. So this is 9 and this is 1. 17 minus 8 is gonna give us 9. 9 minus 4 gives us 5. 1 minus 9 we can't do, we need to borrow. So 4. Put a 1 here. 11 minus 9 is 2, and 4. Bring down that 4. So we have our answer is 4,259. 4,259. Excellent. Now let's talk about dollars, right? So for part B, for example 2, we have $5 minus 25 cents. Now this is why I love Saxon using money as math, or as adding and subtracting, because you can probably do this mentally, right? Let's say you have $5 and you take a quarter away. You would have $4.75, right? So you can kind of think about that and do it mentally if you can. If not, let's talk about how to do this by showing our work. Now remember, our decimal is at the end if it's not shown. So we have $5. And we need to convert that 25 cents into 0.25 of a dollar, 0.25 of a dollar. So we're going to subtract, and again, I like to use that placeholder, so I'm going to use a 0 here, 0.25. Good. Now, to subtract here, I can't do that, and I can't borrow from a 0, so I'm going to go all the way over here, do 4, make that a 10, okay? Now I'm in a position to borrow. Cross this out, it's 9, make that a 10. 10 minus 5 gives us 5. 9 minus 2 gives us 7. Don't forget, we've lined up our decimals here so that we can bring it down nicely. And we have 4. So $4.75. Awesome. All right, so let's talk multiplication now. There's a couple of videos that I've done online that you've seen different ways to multiply, okay? So the first one, I'm looking at example 3 here, and it's 164 times 23. A couple things here. First, you will see that there are a couple different ways to write the term multiplication. Oh, wait, before I forget, write this down. Product equals multiplication. So that's the answer to a multiplication problem, your product, okay? So there are a couple of symbols that you're gonna see that we use for multiplication. We use this lovely dot that you see right here. You may have seen it like this with an X, okay? You may also see it like this with parentheses. All of those mean multiplication. This book, Saxon 87, gets into a lot of pre-algebra, so I'm gonna want you to get away from using that X. That's not to say that we're gonna totally give it up, but it's helpful to get away from it because as we get into some more algebra, it can be confusing if we use that X. So we have 164 times 23. Now I'm going to show you two different ways to multiply here. You're probably familiar with this first one. In fact, your parents probably are too. This is where we go 164 times 23. Okay? We do 4 times 3, which is 12. 6 times 3 is 18 plus 1 more. Do you notice I carried that 10, by the way, from 12? 6 times 3 is 18 plus 1 more is 19. Carry that 1. 3 times 1 is 3 plus 1 more is 4. Now, we're going to do the 2s, so we're going to drop a 0 down here. 2 times 4 is 8. I'm going to get rid of these just so I don't accidentally add them again. 2 times 6 is 12. 2, carry the 1. And 2 times 1 is 2, plus 1 more is 3. Add these all up, we get 2. I should put a little plus sign. That's 17, carry the 1. We get 4, 5, 6, 7, 3,772. 3,772. I sometimes use commas for thousands. I definitely use them when it gets to 10,000 and above, but sometimes for 1,000. Sometimes I don't. I go between the two. Okay, so this is a different method of multiplying, which I really like. It's called the box method or distribution method, okay? If you think back to I think it would probably be about 5th grade, where you learn the expanded form of a number. We know that 164 isn't just 164. It's 100 plus 64 plus, 100 plus 60 plus 4, okay? We're gonna do that times, and it's not just 20, it's 20 plus 3. So this is a 3-digit by a 2-digit. We're gonna draw a box, and it's gonna be our 3-digit by 2-digit box. So we got 3 by 2 right here. Excellent, 3 by 2 right there. All right, so with that said, I need to clean this up a little bit so that I have some more room. You would think by doing this all the time, I would draw decent boxes. No, it doesn't happen. Okay, so on the top, we're gonna put our 164, but we're gonna do it in expanded form. 164. On the side, we're gonna do 20 and 3, but we're gonna do that in expanded form as well. Now what we wanna do, we're gonna multiply. I don't know if you remember Battleship, that game where you do A1 or A13, and you look at A and you go over, and then you look at 13 and you go over like this. We're gonna do the same idea. 20 times 100. Remember, that's just 2 times 1, which is 2, plus 1, 2, 3 zeros. Okay? 3 times 100 is 300. 6 times 2, you can go in any order, but that's 12 plus 2 zeros. 3 times 6 is 18 with a 0. 4 times 2 is 8 with a 0, and then we got 12. Now, the reason why I like this method is we're going to add all these up to get this number, this same number. As you get better at this and as you practice, you can start to do it mentally pretty quickly. But for right now, what we'll do, and the reason why I say that is because if we look at 1,200 and 300, that gives us 1,500. So 2,000 plus 1,500, which is 1,500, That gives us 3,500. So now we've gotten those out of the way, right? 3,500. 80, we'll just go ahead and put these all here. Like I said, if you can do it in your head, that's great. If not, don't worry about it. We'll get there. So we add all these guys up. We have 2, 8 and 8 is 16, plus 1 more is 17, 5, 6, 7, and 3. And do you see we get the same answer that we got here? So it seems like it might be a little bit more time consuming, but the deal here is if you practice it, it becomes actually a lot faster because you can do, this puts it in nice little like place value groups, so it's a little bit easier to do. Okay, so that was our example A. Now what we're going to talk about is our example B. We're still on the example 3, part B. This guy says $4.68 times 20. $4.68 times 20. Now, with multiplying decimals, regardless of how you do it, you just want to treat it like a normal problem. So we're not going to do $4.68 times 20. We're actually going to do 468 times 20. Here's the good news. When we're multiplying by something that ends in a 0, we actually don't have to line it all up like this. We don't have to do that because then that's going to give us a whole other row, blah, blah, blah. What you want to do is 468 times 2 with an extra 0. We got to remember to slap that extra 0 on the end. That's this guy right here, okay? So 8 times 2 is 16. 6 times 2 is 12 plus 1 more, 13. Carry the 1. 4 times 2 is 8 plus 1 more is 9. Bring down that extra 0. So this guy is 9,360. However, we have to deal with the decimal. We look at the original problem, and remember, if our decimal is not shown in a number, it's at the end. So right here, the decimal's at the end, right? But right here, we have 2 digits that are behind decimals, 1 and 2, okay? That means when we've got our final answer, whatever method you use to get it, you're gonna take your decimal and you're gonna move it in however many digits there are, and there are 1, 2. So we're gonna move it in 1, 2. So our final answer is $93.60. Remember, and means decimal. So $93.60. Okay? Let's see. Okay, so for example 3, part C. 5 times 29 cents. And there's that parentheses I was saying. That's another way of using multiplication. So 5 times 29 cents, we're going to do this. 29 times 5. 9 times 5 is 45. Yeah, it would help if I wrote it in the right area. Also, if you guys don't have one, get yourself a 20 by 20 multiplication chart. You can find it in my group, in my Google Classroom. That way you've got something that you can quickly reference. However, with that said, learn your multiplication tables. It'll make algebra go so much faster. Okay, 5 times 2 is 10, plus 4 is 14. So when we come over here, you notice we have that cent sign. We have 145 cents. But you probably never hear somebody say, I have 145 cents, right? We want to convert that into dollars, Now there's no decimal shown here, which means it's at the end. In order to convert into dollars, we need to move it over 2 spots, okay? So it's going to be $1.45. $1.45. Excellent. All right, next one is division. Division, and the word for division, the answer to a division problem is called your quotient. Hopefully I'm spelling these right. My goodness. That means division. You would think after years, I can't spell the word reciprocal to save my life. So hopefully I've got this. Even after 15 years of doing this, I still mess up reciprocal. Okay, so quotient is division. That's the answer to a division problem. Looking at example number 4, we have part A. It says 1, 2, 3, 4 divided by 5 and 6. Friendly reminder on how to do long division. We take this garbage that's here at the beginning and we put it under our table, 1, 2, 3, 4. And then the divisor is this guy right here, 56, okay? 56. I'm gonna do some side math just so we have it, right? 56 times 1 is 56. 56 times 2 is 2, carry the 1. It's basically doubling 50 and then doubling 6, right? So it's 112. So I'll just write 56 times 2 is 112. 56 times 3, we get 18, carry the 1. That's 15 plus 1 more is 16. All right, this is going to come in handy just to have a couple of these. dashed out to the sides. All right, so 56 cannot go into 1, it cannot go into 12, but it can go into 123. 123. And how many times does it do that without going over? It looks like 2 times. So we're gonna put a 2. Notice how I'm putting it over the 3. That's because I'm saying, hey, it goes into 123. Guys, if you need to draw some lines to like keep all of your division nice and lined up, that is totally acceptable, okay? The key here is being organized. That's the key in math anyway. The first step is writing the problem down correctly. The second one is staying organized. All right, so 2 times 56 is 112. 112. We go ahead and subtract here, and in order to do that, we get 1 and 1, so we get 11. Every time we subtract, we also bring down, okay? So now we have 114. How many times does 56 go into 114 without going over? Still 2. So we're gonna put 2. 2 times 56 is 112. Okay, I'm gonna get rid of this 3 over here. Got a little excited about multiplying. Okay, so when we get that, we subtract here and we have 2. We're done at this problem because there's a decimal here, so there's a decimal here, right? So that means we just have a remainder of 2, a remainder of 2. Let me just double check that they want, yeah. So for right now, we're just gonna do remainders. We'll work on decimals later. So 22 with a remainder of 2. All right, and you notice we use that division, this guy, for division. There's also another way to write division, and it looks like this. 1260 divided by 5. Guys, you're probably looking at me going, lady, that is a fraction. What are you talking about division? Turns out fractions are just division. Fractions and decimals and ratios and percents, guys, those are all the same thing. So that's all it is division. This is our divisor down here. So if it's on top of the table here, it needs to go under the table when we go to divide. Now, you may have heard me say about that decimal before. We didn't have a decimal in the previous one, but we do now. We need to bring that decimal up, okay? We can never have a decimal over here, and in later lessons, I'll teach you what to do. So how many times does 5 go into 12 without going over? 2 times. 2 times 5 is 10. We go ahead and subtract, and every time we subtract, we bring down. 5 goes into 26 5 times, right, without going over. 5 times 5 is 25. Subtract that, and when we subtract, we bring it down, we get a 0. 5 goes into 10 2 times, and 2 times 5 is 10, so we have 0 remainder. That is our answer. If it starts with a dollar sign, guys, you need to use a dollar sign to show your units, okay? All right, so those are the examples from this problem. If you want to stick around, I'm going to do the practice problems. What I would advise you to do is go ahead and pause now. Try those practice problems A through I, and then we'll go through those pretty quickly, okay? Okay, so for A, it says this sign is incorrect. Show 2 ways to correct this sign. And the sign, I suppose I can just show you the book. This sign right here is incorrect. And if you look and see, it's got 0.45 cents. I don't know how to focus this, I'm sorry guys. 0.45 C. Now this is what I told you back at the beginning of the lesson. You can't do that. Can't do that. 45 cents can't be written like that. You're telling me you want 0.45 of 1 penny. That's not a lot of money. So 45 cents can be written like that, and 0.45 of a dollar. So if that's what you got for A, congratulations. B, name a whole number that is not a counting number. And I just realized we skipped this part at the beginning. I totally spaced as I got really excited about adding, subtracting, and multiplying. So let's talk about whole numbers. Okay, so here's how it starts out. Counting numbers are things that you can count. So we're looking at like 1, 2, 3, 4, 5, not 0, okay? After that, a whole number is 0 and all your counting numbers, okay? So a whole number, 0, 1, 2, 3. Counting numbers, counting natural numbers. That's 1, 2, 3, dot, dot, dot. I forgot to put dot, dot, dot here, okay? You'll get into this a little bit later, we will. Integers, and oh my goodness, integers. I got really excited there. Integers. We will talk about these later, but those are our whole numbers plus their opposites. So -3, -2, -1, 0, 1, and 2, and dot, 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 right? Okay, so let's look at C. When the product of 4 and 4 is divided by the sum of 4 and 4, what is the quotient? Whoa, we got some words there. When the product, which means multiply, when the product of 4 and 4, so 4 times 4 is 16, right? So when the product of 4 and 4 is divided by the sum of 4 and 4, sum means add. So when it's divided by the sum of 4 and 4, and the sum of 4 and 4 is 4 plus 4, okay, the quotient, or what is the quotient? And remember, quotient is the answer to a division problem. So 16 divided by 8, we get 2, okay? All right, so then let's look at D. For D, we have $1.75 plus 60 cents plus $3. Okay, remember we add across, or add straight down, so we get 5. 7 and 7 is 14, therefore this is 13. Bring down your decimal, carry your 1. 3, 4, and 5. $5.35, and we're talking dollars, so throw your dollar sign in there. All right, E. $2 minus 47 cents. All right, we can't borrow from here, so we gotta borrow from here. This makes this a 10. We can borrow now, 9. So we get 3, 5, bring down your decimal, 1. Use your dollar sign. That's your answer for E, okay? All right, for F, we've got 5 times 65 cents times 65 cents. So it's going to be 0.65 times 5. This times this is 25. 30 plus 2 is 32. Now we have 2 digits that are behind decimals, 1 and 2, right? So we're going to bring this over, 1 and 2. Our decimal's going to go there. It's $3.25. $3.25. All right, so for G, we have 250 times 24. 250 times 24. Really what this is 25 times 24 plus a 0, right? So we're gonna do, like, I'm gonna do that box method, right? And I'm only doing a 2 by 2 because I'm just getting rid of that 0 because I'm just gonna slap it on the answer at the end. So 25, 24. This is gonna be 400. This will be 80. This will be 100 with a 10 with a 0, sorry. And this will be 20. 80 and 20 is 100 plus this is 200 plus 400 is 600. 600. Okay, but we have to add that other 0 on the end, right? So it's actually 6,000. 6,000, okay? Let's see, we've got H, 24 divided by, so $24, oops, it said dollars with decimal with 2 zeros, divided by 5. $24 divided by 5. All right, so we got 5, our divisor. This goes under the table, 24.00. 5 goes into here 4 times without going over. We subtract, and when we subtract, we bring down. Our decimal's right here, so we need to carry it up. 5 goes into 40 8 times. 8 times 5 is 40. That's 0 and a 0, which means it's not just 4.8, guys. It's $4.80. $4.80, okay? You got to throw a 0 on there. If you go to the store and you're like $4.8, they're gonna say what? You know, $4.80. All right, so one more. 234 divided by 18. 234 divided by 18. This is I. All right, I. All right, so what we say is this is our divisor. 2, 3, and 4. Now, when I say a 20 by 20 multiplication chart, I'll show you why. All right, so you see this guy? Oh, it would totally make more sense if I showed you here. Okay, so this is our 20 by 20 multiplication chart. So you can see that I have all of my 18s here, nice and lined up. So 18 goes into 23 without going over 1 time. Okay, 1 times 18 is 18. That's how I got that. So subtracting, I get from 18 to 20 is 2. From 20 to 23 is 3. So that's 5. When I subtract, I bring down 5 times 4. We go over to 18. How many times does 18 go into 54? Looks like 3 times. 3 times, okay? 3 times 18 is 54. We have a remainder of 0. All right, so that is lesson 1, guys. It's quite a bit of work, but I hope you enjoyed it, and I will see you for lesson 2. Let me know if you have any questions.